This question is from the Year 12 Maths Quiz textbook, Chapter 5b, Question 10. The question gives that the acceleration of a particular car from rest is given by the expression that a is equal to 3t square root of t squared plus 4 for time between 0 and 5 seconds. So first of all, we've got to find the velocity at any time. So we know that velocity is equal to the integral of the acceleration. So we've got to integrate our expression that we've been given, 3t t squared plus 4, and that's with respect to time. So to do this integration, I'm going to use a substitution. So I'm going to say let u equal t squared plus 4, and that will simplify things. So I can then differentiate this and say that du dt is equal to 2t. What I'm looking for though is to be able to substitute for this dt here. So I'm going to rearrange here and say that dt is equal to du over 2t. I'm going to call that equation 2. So now sub equation 2 into equation 1. So that will give us velocity is equal to the integral of the 3t won't change, but now instead of t squared plus 4 to the half, we're going to have u, and rather than write the square root, I'm just going to use the 1/2 symbol, and instead of dt now, we know that we have du over 2t from my substitution. I can now see that the time is going to cancel out, so that's going to mean that I'm integrating 3 over 2, and we've got u to the power 1/2 du. So we'll have a 3 on 2 as a constant at the front. Now when I integrate the 1/2, that becomes a power of 3 over 2 because it increases by 1. That means we also divide by 3 over 2 and add on our constant. Now the 3 over 2 will cancel with the 1 over 3 over 2. So we've simply got u to the 3 over 2 plus c. Now we need to substitute back in for our value for u. So we had initially said that u was equal to t squared plus 4. So putting that back in now, we've got this expression for our velocity. Now we're told that it's starting from rest, so that means that when t equals 0, v is equal to 0. So I'm going to put that in now. So 0 is going to be 0 plus 4 to the power 3 over 2 plus c. So c is going to be equal to negative 4 to the 3 over 2, which gives us negative 8. So now subbing back into this equation here, we've got velocity t squared plus 4, 3 over 2, and take away 8. So this is our answer for part A, the velocity at any given time. For part B, we've got to find the time to the nearest hundredth of a second when the car reaches 56 kilometres per hour. So first of all, I need to put B is equal to 56. So we have 56 equal to t squared plus 4 to the power 3 over 2, take away 8. So now I need to add 8 to both sides. So we're going to get 64 is equal to t squared plus 4 to the 3 over 2. Now I need to get rid of that power 3 over 2. So if I multiply by 2/3, the 3 over 2 and the 2/3 will cancel each other. So if I'm raising this to the power of 2/3 on the right hand side, I need to do the same on the left hand side. So 64 to the power 2/3. Using a calculator, that will give me 16 on the left, and because my powers cancel here, I'll have simply t squared plus 4. Subtracting 4 from both sides, we get 12 is equal to t squared, so t will be equal to the square root of 12. Now because we're talking time here, it doesn't make sense to have a negative value, so when I work that on my calculator, I get 3.46. Therefore, it takes 3.46 seconds to reach 56 kilometres per hour. That's the answer to part B.